Hi, this video is on how to set the relay contact alarms on the FLT93. Hi, my name is Alan Kuge and I'm the Inside Sales Supervisor and the Product Knowledge Workshop Manager at FCI. The FLT93 switch is a flow, level, and temperature switch and it can be used in any of those three applications. Today we're just going to focus on how to set it up for a flow application using an FCI portable training stand here. First thing you want to do when you get the switch is you want to remove the cover, and if it's an integral unit like this, and by the way this comes in integral or remote, if it's a remote unit you'll have a separate enclosure with the circuit board in it. This is an integral unit, so the circuit board is installed right inside the probe enclosure. You pull the circuit board out, and inside you have a socket where you hook up your power wires. The wires from the sensor head are already pre-wired. The circuit board jumpers for different applications like liquid or gas can be set. You have heater wattage settings, J32 for liquids, J13 for gases. It has two relays on the circuit board. They're single pole double throw relays. They can be jumpered together as a single double pole double throw relay. And you also have energization control. You can have it energized on flow or de-energized on flow. So all of those are selectable, and you have the input power jumpers as well, so you can use it for AC power or DC power. So once you have all your jumpers set, and by the way, you can find all these instructions in the operation guide, which is available on our website. Also, one of these is sent with every instrument that we ship. Now, installing the instrument, you thread it into the pipe. If it's a flange unit, of course, you have to flange it on. And you make sure that the flat, which is marked with an arrow, is parallel with the flow. Then you have it installed correctly. The insertion length should be determined before you purchase the instrument based on how big the pipe is. We have variable lengths, longer lengths for bigger pipes. To begin our demonstration, we have the FLT93 installed in the pipe. We have power. You can tell by the lights on the LED. We have the voltmeter set on DC volts, 0 to 20 volts. It's connected to the P1 connector, pins 1 and 2, which provide the voltage output that goes with the flow. And just so you know, pins 3 and 4 are for the temperature output. So the first thing we're going to do is take a voltage reading in a no-flow condition. We have no flow in our portable training stand right now. We have about 3.5 volts coming out of the flow switch. Now we're going to turn the power on, and we're going to note that as the flow begins to occur, the heater is cooled on the sensor. This reduces the temperature between the two RTDs. There's a reduction of the delta R signal, and as a result of that, the voltage also goes down. We're going to allow the voltage to stabilize, allow the flow to stabilize, and that's about right, 1.5 volts. So now we know that our voltage in a flow condition is 1.5, and our voltage in a no-flow condition is 3.5. Now we'll shut the fan off, and I'm going to demonstrate how to set a trip point right between the 1.5 volts for flow and the 3.5 volts for no flow. So we'll set it at 2.5 volts. And we do that by turning the mode switch from the run position to the calibrate position, and then we dial in on the R24 potentiometer, which is right next to the mode switch. We dial in 2.5 volts. See, I can make the voltage change to whatever I want here by turning the set pot. So I'm going to turn it so that it has 2.5 volts. If you turn clockwise, the voltage goes up. Counterclockwise, the voltage goes down. I want to get it right at 2.5. I've got it at 2.5. Okay, now I'm simulating a flow condition that's right between flow and no flow. And so I can set my alarm. I'll come up here to potentiometer number R26 for alarm number 1, right next to the red LED. And if the LED is on, I'm going to go counterclockwise until it goes off. And then I'm just going to go back again till it's on. Now, I'm setting an alarm to detect a loss of flow condition. So I want to have the LED on to indicate a loss of flow. Think of these alarm LEDs like stoplights. When they're on, it indicates a loss of flow. It's like stopping. The flow is stopped. So I want the alarm condition to be they have the LED on. Okay. All right. So now the next thing we do is we put the switch back from the calibrate mode into the run mode. And you notice the voltage now changed to our no flow voltage again, because now it's actually measuring the voltage that's coming from the sensor. When it's in the calibrate mode, it's measuring the voltage that I dial in, and when it's in the run mode, it measures the voltage that's coming from the sensor. So now we're going to turn the fan on and watch the voltage go down. And at the same time, we'll keep an eye on this LED. See how it just went off? That indicates flow. Of course, as the velocity increases, the voltage will continue to drop, but the switch is already indicating flow. Now we can turn the fan off, and we'll watch how the voltage starts to rise again, and when it reaches 2.5 volts, the relay will click on. Watch the LED right there. There you go. Okay, what I've demonstrated so far is how to set up the switch according to the way the manual gives you instructions to do so. And the manual gives you instructions to set a trip point right between the voltage that you see at full flow and zero flow. And that will give you an equal response time in both directions. However, if you want to optimize a set point, for example, going from no flow to flow, what you do is you install the switch in a pipe that has no flow, and you leave the switch in the run mode, and you simply turn the set pot for relay number 1, in this case, until the relay just comes on, and then you turn it an extra half turn. Now if we turn the flow on, see how quickly it goes off? You get a very fast alarm. All right, the other way is when you have flow in a pipe and you want a fast response to detect a loss of flow. While the flow is occurring in the pipe, you leave the switch in the run mode and you simply turn the set pot for the relay that you want to set. Again, if the light's off, now you turn it clockwise until the light comes on. And I'm going to turn a little bit back counterclockwise now until the light just goes off. And now we're going to turn off the flow, and we'll see how quickly we get an alarm. There you go. Everything that I've been demonstrating so far pertaining to relay number 1 can be applied to relay number 2. You have 2 separate relays. One can be set for flow. The second one could also be set for flow at a different velocity. Or you could have one for flow, one for temperature. Or you could have one for flow, and you could have one for a fail-safe detection. This is why we call it the flex switch. It has many different functions that you can use on it. Also, the mode switch can be set up to do a self-test function. Notice as I put it into the calibrate mode, both LEDs come on and both relays change state. Put it back in operate, they go off. So it's a nice feature that you can use to make yourself feel comfortable that the switch is operating in the field just by clicking the self-test feature, and you can see that the relays are changed in state, and then put it back in the run and you're good to go.